So, vitamin A, what type of vitamin is vitamin A?
That's fine.
It's a fat soluble vitamin. And in general, what do you know about vitamin A? What's it important for?
Vision?
Vision. More importantly, so you need it for vision. That's why your parents told you to eat your carrots. But really that was essentially to prevent night blindness. So it wasn't going to make your eyesight become better. It wasn't going to keep you from having to eat or keep you from getting glasses or needing contacts. It's just all about having proper function of the eye. But everything else that vitamin A does, so this is in the eye is the main place that vitamin A acts like a true vitamin. So it's when the light hits it, it changes conformation, and with that change, that's allowing you to see. But everywhere else in the body, it is acting like a steroid hormone. You guys know what a steroid hormone, how that works?
You say something with oxidation?
Yeah.
No.
I remember talking about it, but I remember what I said was wrong.
So a steroid hormone is something that you can take. It goes among all different animals. So testosterone is testosterone. It's not like testosterone from a gorilla isn't going to affect you. It will. And part of that is the steroid hormones can enter the cell, and they are binding nuclear hormone receptors, which cause gene transcription. So that's why hormones in general, where you get if you were to take testosterone, the performance enhancing drugs like testosterone, you're going to see increased muscle development and everything. But vitamin A works in a similar manner. So vitamin A in the form of retinoic acid, it binds nuclear hormone receptors, and once it binds those, it can transcribe genes. And it's through this mechanism in which it's affecting reproduction and immune function and everything else. The main sources of vitamin A within an animal diet is primarily going to be through our corn. Our corn has a lot of beta carotene in it. So even though beta carotene is a carotenoid, it is one of those carotenoids that has vitamin A activity. So we can convert beta carotene to vitamin A within our intestine and then absorb it as vitamin A. And then another way is that we get it is retinol palmitate. Where do you think we're going to primarily be getting retinol palmitate in the diets of fish and poultry?
Seaweed?
No. What ingredient that you played with on Monday would have it? So retinol palmitate is going to be the form that we're using in our vitamin mix. Naturally, retinol palmitate is going to be, this is the way in which your body stores vitamin A, and it stores vitamin A in your liver. So if you eat a lot of liver, like if you like chicken livers, you're going to meet your vitamin A requirement because you're getting vitamin A from the chicken livers. So this compound, you have the retinol. Do you remember that compound that I drew? This is not going to be exactly. Right, approximately like this. So this is our vitamin A, and our retinol palmitate, we end up having it bind so we just gotta imagine that there's 18 carbons there. So is the vitamin A molecule bound to palmitate, which is a fatty acid. When you have inadequate vitamin A, you get various deficiency symptoms. One is conjunctivitis. Have you guys heard of conjunctivitis before?
Yes, I don't know what it is.
Have you?
I've heard of this, but I don't know.
Anybody ever have pink eye?
Okay, that makes sense, okay.
So what's pink eye?
When you get matter in your eye, correct?
Well, that's one way. So conjunctivitis is just an eye infection.
Okay.
So pink eye is a type of conjunctivitis. You also have malformations in the fetus. You're going to have issues with your nervous system, and you got this thing called squamous metaplasia. So this has to do with changing the epithelial cell type. So this is where vitamin A is affecting cell differentiation. So typically within your eye, and this is going to your conjunctivitis, why you get an eye infection with vitamin A. Typically, the cells are going to be columnar, like this. One layer of cells. We have tight junctions, so nothing can get in between here. And then, so this is in your eye, and it's also in your intestine. This is columnar epithelial cells. Squamous metaplasia, if you're deficient in vitamin A, we end up going from this columnar to where we become squamous epithelium. And it makes your cells be more like your skin cells. So you end up having where these cells down here are alive and these slowly die. And that's essentially how our skin, how we're protecting ourselves. So we have a bunch of layers, so it's more difficult for the bacteria to go through. But we end up not being able to get all of these layers like we develop in our skin. So we lose the tight junction, so you have the little bacterium, and they can go into your blood. And then that results in your immune cells having to go fight the little things, and they're gonna phagocytose it. And so the stuff that ends up being in your eye, do you guys know what that actually is? So that's pus. Do you know what makes up pus? So it's your dead immune cells, dead cells, hopefully dead bacteria that come through it. So that's what conjunctivitis is. So that's why vitamin A causes conjunctivitis. It's also if you end up having this affect your intestines where you get squamous metaplasia. There, you're not going to be able to absorb the nutrients like you should. So you get, inhibit the absorption. Vitamin A is also, it is the leading cause of mortality of children under 5 throughout the world that's preventable. And it's primarily, you're going to find it in Southeast Asia and the Middle East, Africa too, but Southeast Asia. So why do you think children are so susceptible to that? What do they eat in Asia?
Rice.
Rice. What color is rice?
White.
White. What else do they eat with the rice?
Soy sauce.
What?
Soy sauce.
Soy sauce. Okay, if you think more South American, what do they eat with the rice? What's their protein source? Beans. Beans and rice. Beans and rice. How much vitamin A are you going to get from your beans? Not much. So their primary diet, beans and rice, is significantly deficient in vitamin A. Their mothers are also significantly deficient, so even when they're nursing, there's no vitamin A going into the milk, so it exasperates the deficiency. And because of this, there is a company about 10 miles up the road that developed GMO to combat this. Is do you have any guess? It has to do with rice.
The golden rice?
Golden rice. Do you know who made it?
I forgot, but it's.
Syngenta. Syngenta developed golden rice, and that was, so they genetically modified it so that beta carotene would be stored within the grain. I'm also on a committee of a student here in the nutrition department. She's getting her PhD in here, but her research is being done in Kenya. And I didn't know this until her presentation. In Kenya, they eat a lot of sweet potatoes, but they're white sweet potatoes. And there's a lot of vitamin A deficiency all throughout Africa, so she's trying to incorporate switching them from white sweet potatoes to orange sweet potatoes, so then people can meet their vitamin A requirement using beta carotene.
Do they still go the same as the white ones?
But it's changing perception of people. They don't want to eat, because they'll make like potato pancakes. They have all this flour, so where we're using wheat flour, they'll use potato flour. And so then you're eating bread that's orange instead of white.
Yeah.
So it's, and if you've ever dealt with kids before, you know that just takes a long time for them to get used to.
So if a mother is pregnant and she has a low deficiency in vitamin A, will that make that child not be able to have like 20/20 vision, or?
A lot of times they're born blind, so they'll start, you get this other disease called exothermia. There's a P on there somewhere. But exothermia ends up occurring to where the cornea gets really hard, so that happens to where it's just overabundance of fighting this conjunctivitis all the time. So they have so many eye infections on a regular basis that it ends up that their immune cells causing all that pus is going to break down the cornea, and it actually gets really soft on the inside, and there's no reversing that. You also can get night blindness, so that's where You have it to where you don't have the retinol to do the vision component, so, see, is it the rods don't fire, and so you can't see at night.
So you can't dilate your pupil?
You can dilate your pupils, but it doesn't matter because you can't, there's not enough power of the light at night to cause that reaction to occur compared to during the day. So it's, I think it's rods that are affected. Could be cones, I get them confused. But vitamin A is the most prominent thing that is gonna affect children and is the highest cause of mortality. I did my PhD on vitamin A and I made my, I fed my laying hens, so I used laying hens as a model. I fed them a deficient diet. I fed them 70% of their requirement. So it's not like they're severely deficient. But they didn't have enough for their own function, so guess what they did not put in their egg? Vitamin A. Because first and foremost, it comes you, and then you're gonna devote things to your offspring. So they didn't have enough for their own, so they limited the vitamin A that was put in their eggs, and then I artificially inseminated the hens, got the eggs, incubated them, and I had these chicks, they would live, and they were put on a deficient diet also. I had 50% mortality once their yolk was all absorbed, 5 days of age. I'd go and check them in the morning, they'd be fine. Check them before I left for the day, half of them would be dead. It's just instantaneous that quickly, and a lot of that had to do with the fact that they didn't have enough from their yolk sac, and they weren't getting enough, and they would just die. It was hard to get my numbers. That was the difficult thing. And then it was why did the other ones survive? So this is what you'll see. You get the malformation. So this is with a piglet. So it ends up having malformations. And that's because vitamin A is controlling the genes that are turned on and turned off, which are controlling differentiation. So you have cells that are unable to differentiate to do the proper function that they needed to be. Does that make sense? Here, I know this isn't the best picture, but this is a laying hen, and she has conjunctivitis, so her eye is all swollen and watering. If you leave that for a long period of time, you'll end up getting the exothermia.
Did your laying hens have conjunctivitis? Or was it
The laying hens did not, but the offspring did. So if the laying hens, if I would have given them less, so my first study with them, I actually did it in Japanese quail. I listened to my advisor. So when I was saying, what levels should I start off with? And he said, you should be able to do 0. So I did 0. Nothing hatched. I had no, and they very quickly depleted their storage of vitamin A, so they only lasted about 3 or 4 weeks, and then they started dying. But I did see conjunctivitis in the offspring, so I needed 70%. You're not going to see it as much, but the offspring definitely had inadequate amounts. Any questions on vitamin A? Okay. My next second favorite vitamin is vitamin D. This is also a fat-soluble vitamin. It's known as the sunshine vitamin. Why do you think it's known as the sunshine vitamin? Because you can make it from the sun. So if you can make it from the sun, why do we have to put it within the diet?
Make sure you get enough.
make sure you get enough. What is the barn look like?
There's no outside.
Yeah, it's also.
There's no outside light. So we have to have it in the diet. So potentially your free range chickens are gonna be able to synthesize it, pasture, that they can go outside. So what happens is they can make vitamin D, so they have this pre-vitamin D compound, which is 7-cholecholesterol. And that you put in the skin. Now, that's for us, we put it in their skin. For laying hens, they're gonna put it in their preening gland. And then they're gonna take, when they're preening their wings, so they're gonna, you guys know where the preening gland is?
You're behind it, right?
Yeah, it's on their tail.
Yeah.
So there's a little gland there, and that's where they're gonna put it in. So they make various oils, and they take that, and that's what they're using to preen their feathers. And when they're doing that, they're putting this pre-vitamin D on their feathers, because they don't have very much exposed skin, right? So they're putting that on the feathers, and as they're preening themselves, they end up consuming cholecalciferol. If you make vitamin D these different ways, you cannot get toxic levels, because as the animal has sufficient amounts, they're going to stop making this pre-vitamin D. What happens to us as humans? How are we going to prevent vitamin D toxicity? If you stand out in the sun,
So like the
Burn.
sunburn.
so you're going to get sunburned. So people that have darker skin, that melatonin within their skin, what's giving them their skin pigmentation, is a natural sunblock. Why are you getting sunburned? That's your body's way of protecting you from making too much vitamin D. So having darker skin is keeping you from making too much. Yeah.
What happens if you do make too much? Like you eat a lot of it, and your body can't like burn, like when you.
Then you get potentially soft tissue calcification. So vitamin D, do you guys know, when you think of vitamin D, what do you think of? Why you need to have it?
Immune system.
Immune system? That's your number one
I
thing?
think of bones,
Was it, Tyler?
like your bones.
Bones. So vitamin D is critical for calcium absorption and reabsorption. So you need it to absorb calcium from your intestine. And where do you store calcium? In your bones. So the more calcium that you have, that you're able to absorb, you're gonna put more of it in your bones, and you're gonna get strong, healthy bones. But you need vitamin D for that. Be-
Can you overdose on vitamin A?
Yes. Vitamin A is the most toxic, but the least stable. So, but in the grand scheme of things, you're not, one, with vitamin A, you can't get toxic using beta carotene, because your body's just gonna stop converting beta carotene to vitamin A in your intestines. But what you would end up doing is you're still gonna absorb that beta carotene and you'll look orange. So some people that overconsume too many carotenoids, they're gonna end up storing that in the fat and in their skin and stuff. So their skin will turn orange.
Is there like an overdosage on the water soluble? Because
No, not really. So that's the main difference between our fat soluble and water soluble. Is our fat soluble, you can get toxic amounts, primarily of A and D. Now, it takes a lot. It takes a lot to get to that, but A is the most toxic out of all of them. D is probably the second most toxic, but even so, it takes a lot of vitamin D to get to the toxic levels. We do supplement this in poultry diets and in fish diets because, well, fish, we're not providing them necessarily their natural food source, so they all start, the fish originally get it from the phytoplankton and the algae that's making the vitamin D, and that's how they get it. That's where you get high levels. That's how we discovered vitamin D, because before we knew what it was to cure the disease of rickets, like your great-grandparents probably had to, potentially grandparents probably had to take spoonfuls of cod liver oil to prevent rickets. Do you guys know what rickets is?
Is it something sailors used to get?
No, that's scurvy.
That's good, okay. Then.
So rickets happens with children, and it's when they don't have adequate bone density. So they're growing, but their body mass gets so great that they end up getting bowed legs, and then it calcifies. So that's what rickets is. You get more of the bowed, because your body can't hold up the weight. Your skeletal structure can't hold the weight of your body, so it starts to give, because your bone density is so low. And then your bones calcify, and then you're stuck with rickets for the rest of your life. You also, as an older adult, you'll get osteoporosis. You guys hear of that before?
Yes.
So osteoporosis happens in which population? Old people, specifically what type of old people? What? Currently, yeah, but men or women are more prone.
Oh, women.
Women are more prone to it. And so the main form of vitamin D is this 125 dihydroxy. That's also known as calcitriol. Vitamin D, it's known as cholecalciferol. So this is the active form. This is the most highly controlled level or thing that we're going to have. This is the compound that binds the nuclear hormone receptor called vitamin D receptor, or VDR. I know that can be really tricky to remember. Vitamin D binds the vitamin D receptor. And it's maintaining calcium homeostasis. So calcium is one of those critical minerals that your body is going to do everything in its power to maintain your blood calcium levels. It's almost like pH. It wants to, your pH is a 7.4. It's going to do everything to maintain that. Same with your blood calcium. And it's going to compromise your bone structure to keep that level of blood calcium. And that's because calcium is probably, everybody thinks of bones because that's where you can see the deficiency happen the most, but calcium is involved in so many reactions. All your muscle contractions are all due to calcium. A lot of your signaling pathways and how you're turning enzymes on and off within your cell is all through calcium. So it's very critical, and we need to maintain it. So if our blood calcium level drops a little bit, we're going to end up increasing our 125, which is then going to increase calcium absorption from the intestine, and it's also going to start breaking down bone calcium to maintain that. And once we get high enough blood calcium, it's going to start putting calcium back in the bone. Does that make sense? And then it's also involved in immune function. So vitamin D is very similar to vitamin A. And a lot of that has to do with the fact that they work in a similar manner using this nuclear hormone receptor. And I'll preface this that vitamin D is actually not a vitamin, classically looking at its function and how it works. The only reason why it's classified as a vitamin is because we discovered its association with calcium first. But vitamin D, just like vitamin A, is a steroid. Any questions on that so far?
Is that why they started adding vitamin D to milk for like rickets or?
So here's kind of how vitamin D works. And they put it in milk, Tyler, too, because it has a higher fat content. So like whole milk, when I was little, I always used to call it vitamin D milk. Because the higher fat, you need the higher fat to absorb the vitamin D. And it makes it more ubiquitous, and milk has higher calcium, so it just makes sense to put them together. So you end up, whether you make the vitamin D, your cholecalciferol from the sun, or you consume it, it ends up going to your liver. Within your liver, it's converted to 25-hydroxy-D, also known as calcidiol. This is the way in which your body determines the status. So if you're not sure if you have adequate vitamin D levels and you have your doctor check them, he or she should be looking for 25-hydroxy. 95% of your cholecalciferol is going to be converted to 25. And looking at the human side of things, 50% of the US population is deficient in vitamin D. Would you ever guess that?
No?
Any guesses as to why 50%?
I mean, I guess people are starting to work inside now.
They work inside, and when they go outside, what do?
Sunscreen?
Sunscreen. If you look at African Americans or darker skinned individuals, 70% of that population is deficient because they have to spend even a longer period of time outside to make adequate vitamin D. And the current levels that we believe are what's adequate, especially for humans, some believe are not high enough, because the only way that you can get those levels is either tell people to go outside, which dermatologists don't want. Why don't dermatologists want you to go and spend time outside?
I don't want you to get mold or whatever. Or skin cancer.
Skin cancer. So they're concerned about skin cancer. And so therefore what's the only other way you can get vitamin D if you're not synthesizing it? You add it to the diet. You can take your cod liver oil supplements, but either way, it has to be a supplement. There is no good diet, any good compound or food that's naturally high in vitamin D outside of various fish oils. That's why we fortify milk with it. But then you result in, once kids stop drinking milk, so that gets them through the first 2 years, and sometimes parents, they don't provide them milk very much after 2 years. So they're more prone to get deficient later on. So 25-hydroxy is the status when you end up having, we also use this other hormone called parathyroid hormone, which controls things. When your parathyroid hormone, or when you have low blood calcium, that's going to activate your parathyroid gland, which is on your thyroid. So your parathyroid gland are those little things, that's your thyroid. It's going to release parathyroid hormone, that's going to go to the kidney, and the kidney's then going to convert the calcidiol to calcitriol, which is the 125, which is the active form. This is then going to go to the small intestine and increase the calcium absorption from the small intestine. It's also going to start breaking down bone. Once we get high levels of calcium, this is going to have a negative feedback loop, and we're going to inhibit our parathyroid hormone, so we stop making this active form of calcitriol. So this is why you have 95% of your vitamin D becomes 25, only 25% of your 25-hydroxy becomes 125. So we want this to where it can quickly change. Does that make sense? So this is how it absorbs. But if you end up having a significant amount of vitamin D, really high levels of this 25, you're going to result in getting more 125. And this is taking a lot of vitamin D. So do you guys know what the current recommendation is for people, how much vitamin D you should take a day? So it's now 600. Back in, let's see, 2011, that's when they changed it. Before 2011, it was 200 is what they had recommended. But people only eat about 200 if you look at their diets. So, and some are arguing now that they think the requirement should be more like 5,000 IU a day. They now have the upper limit, which people is saying that you run the risk of getting toxic levels if you go above the upper limit. And so that is setting people at 4,000 IU. Have you known anybody that takes, been treated for vitamin D deficiency? So I had a family member of mine, once I started working on vitamin D, they were kind of telling me, he said, you should ask your doctor to go and check your vitamin D levels. She did, comes out she's severely deficient. So her doctor gave her a large bolus of vitamin D, and that ends up being, when they're treating it, they give you 50,000 international units that you take that once a week, just a large bolus, to treat it. Some will say that you can get toxic levels if you take 10,000 IU a day for prolonged periods of time. And you end up getting the soft tissue calcification. So within your cells, you have your calcium that's stored. It's stored there for all of those reactions. And eventually you're going to override, you're going to have too much of that, and it just results in that you start forming bone in your soft tissue. So that's where they call it soft tissue calcification. I just finished a study looking at ways to naturally increase the amount of vitamin D in the diet, and we gave very high levels of vitamin D to laying hens. So we gave them, I think it was like 1,000 times the requirement, maybe 100 times the requirement. It was 100 times the requirement. So they then took that extra vitamin D, what is a laying hen, if she can't excrete it any other way, what is she gonna do? How's she gonna get rid of any excess?
Isn't it in the egg?
So she puts it in the egg. 'Cause that's her main outlet. So we were able to get eggs that have, normally eggs have 80 international units of vitamin D, and we were able to get eggs that had 850 international units of vitamin D. So we now made it to where you can eat one egg a day and meet your vitamin D requirements, or you can have 2 eggs a day and ensure that you're not going to get B deficient anymore.
And it still wasn't too much to where it affected the chicken at all?
No, so we're evaluated bone health and bone density, looked at blood calcium, and we didn't have any indications of soft tissue calcification with that level. But I think it helps. Now, would you want to do that in a growing animal or a male that can't get rid of it? No. But I think the reason why we didn't see any of that was because the laying hen was able to put so much extra within the egg to keep her from getting too toxic. So we have different forms. There's D2. D2 is known as ergocalciferol, and I'll say that D2 is not as effective of a source. So poultry can't convert D2, they can't utilize it, they have to have D3. Fish can use D2, somehow they're able to convert it. I'm not sure how. But naturally you're gonna see it, anything that is sun-dried is gonna have higher levels of D2. So sun-dried haze, irradiated yeast, because that's causing the UVB is how they irradiate it, and that's gonna cause more, the yeast is gonna make D2, alfalfa meal dehydrated, so all of that, anything that's sun-dried is gonna have D2. D3 is coming from animal sources, so that's cholecalciferol. You're gonna get a higher level of it in ingredients including fish meal and fish oil. Your main symptoms of vitamin D is gonna be rickets, so the softening of bones. And in laying hens, you'll get cage layer fatigue. So that's, they can't stand up. You can see it also in, so laying hens are more prone to it. Anybody guess why laying hens are more prone to calcium deficiencies, vitamin D deficiencies?
Was that making eggs?
They're making eggs. What component of the egg needs more calcium?
The shell.
The shell. You'll also see things in dairy cows. You ever have them out at the dairy get milk fever, Zach?
Plenty.
How do you treat milk fever?
You have to give them an IV and give them calcium.
So you give them, and how quickly, once you start that IV, do they, so they end up, they can't walk, right?
They
just
try and get up, but they just can't.
So why can't they? It's because the calcium within their muscles, they can't contract their muscles anymore. So they can't move. But how quickly do they jump up as soon as you give them?
They get up relatively quick once you get the IV in.
So once you get the IV in, it's within a matter of a minute that they can then move. It's just, and which cattle are more prone, or which cows are more prone to it, the low producing or the high producing?
The high.
The high. Do you know why?
I guess because they're putting all of their calcium intake into the milk.
So exactly, so they're putting, and when do you more likely see it, right after they calve or later in production?
It can be both, but what I've seen more is like right when they calve.
right when they calf. So that's the predominant time in which you're gonna see it, because all of a sudden they didn't need all that calcium and they weren't
Okay.
ready for it, and all of a sudden, all that calcium leaves their blood to go to make milk, just like the laying hens. You're more likely to see it more with them when they hit the peak of their egg laying, and they have it to where all of a sudden they can walk one day, they lay an egg, and they can't move. So they call it cage layer fatigue, and that's all due to the calcium.
And most of the time, it's like the younger heifers too, it's not
Yeah.
the older cows.
Right, so that's where you'll see it with laying hens. We don't keep them, you get 2 cycles, but you bring them back from a molt, you're not gonna see it as often as you will with the younger birds.
As far as D2 goes, would there be D2 in like raisins or like muscadine grape
Yeah.
casings, like do you still get D2 in that?
Mushrooms, sun-dried mushrooms. So the lab that I did my postdoc in, there was a study that we were conducting looking at the efficacy of the sun-dried mushrooms as a alternative to a supplement. And with that study, the thing that we ended up seeing is that although our total 25, it did go up a little bit. Your D2, having your source, at least in people, come from D2, it does not as greatly increase your total vitamin D status, your 25 hydroxy within your blood. You just replace, instead of having D3, you have D2, where if you give D3, you're going to increase the amount of your total 25 hydroxy.
But in fish that say can do D2, it would increase theirs? Or
It
is it
should.
just certain fish?
I need to look it up. I remember having this conversation in a lab meeting there, because we were trying to figure out where the hell fish get their D3 from, and we all ended up leaving that lab meeting and discussing it. But fish at least some fish can convert. I need to look into it more as far as to exactly how they convert it, and more their sources. Okay. We over time now?
2 minutes.
So this is some of the pictures that you get. So this is rickets. A bone should not do that. You also get this thing with laying hens called tibial dyschondroplasia. So that's at the tibial joint, where you end up having it where it doesn't calcify correctly. And that results in when you're processing broilers or turkeys, having tibial dyschondroplasia, it's gonna cause a downgrade because you're gonna be breaking those bones, and then you end up not being able to sell them if you have a broken bone, because the bone marrow and all that is a contaminant potential for bacterial growth. Here you can see this bird. This is it's a hawk, and it has so that has rickets. It can't stand up. You can see that it's more on its haunches as opposed to standing up on its feet. Here's a pig with rickets. You can kind of see the bowing of the legs, and you look at the bones. This is a normal bone, and this is from a pig that had rickets. So this ends up calcifying like this, and so it can't be reversed once it gets to that stage. So you can, that's one reason why you try and do interventions to keep especially kids from getting rickets, because it's irreversible once it starts to happen. we'll stop there and I'll talk. So Friday, I'll put the exam up, I'll probably write it tomorrow, maybe Friday morning.
And it's up until vitamins, right? Like you don't need to know anything about vitamins.
Correct. The only thing that today would be from that first lecture, that intro lecture that we talked.
Just like what is vitamins?
Right,
Pass the labels and stuff.
yeah.